All right, welcome to our quick tip of the day. I have a treat for you. Today, I'd love to introduce to you two Microsoft employees talking more about Spark. We're going to go in deep diving with orchestrating Fabric Spark and best practices for your Fabric production-ready workloads. With me, I'd like to introduce to you Santosh and Ashit. They are from the Microsoft team, doing an incredible job on the Spark engine. Welcome, gentlemen. So happy to have you here. We're really excited to get talking about your slides today.
Thank you, Mike. I am Ashit. I run the Spark runtime team. I'm here to represent a whole bunch of talented folks who are working every day to make Spark better and be the best out there. With me is Santosh.
Hey everyone, thanks for having us, Mike. I'm part of the Fabric product management team. I'm mainly focused on the data engineering workload, which includes Spark, Lakehouse, and the notebooks that everyone loves in Fabric.
Dude, man, I'm right there. I love the notebooks. The notebooks are so good. This is an incredible experience, and us as Power BI developers getting this work that you guys are doing. This is amazing. All right, let's jump in. I don't want to waste any more time. Let's get right into your slides. Here are the slides. We're up and ready to go. Take us away.
Awesome. So the main focus of today's talk is going to be going from your sandbox environment or your proof of concepts on Fabric to going live and scaling it to your production scenarios, right? So as part of this session, we would want to first go through the concept of what is Spark in Fabric and what it powers behind the scenes, and then we want to navigate into the scenario where how critical it is to tailor Spark compute based on the different layers or zones in your lakehouse. Then after that, we want to navigate into the topic on understanding your workload. And once you understood your workload, now you start running it. This is where you actually hit scenarios where you would want to make sure that you meet the SLA for your downstream consumption, how you could best optimize the Spark performance, how you could leverage some of the tools that are available, and some of the tips that Ashit would be sharing so that you are able to scale for your production scenarios, and also have a more resilient data engineering workload. And then we would also want to touch upon, you could achieve the performance. Now, you want to make sure that you balance between the cost, the price that you're paying for your workload, and achieve the best in both. And then we could go into the Q&A. So let's get started. So Spark in Microsoft Fabric, as you know, Microsoft Fabric is a unified sales analytics platform. In this case, you have multiple engines like Data Factory, Data Warehouse, Data Engineering, Data Science, Real-Time Intelligence. Spark in Microsoft Fabric powers the data engineering and data science workloads. So when we talk about Spark, Spark Compute is what powers the workloads. So in this case, when you talk about Spark Compute, it's offered in two major forms. One is startup pools. I'm pretty sure everyone would have tried startup pools if you're running your jobs on Microsoft Fabric. These are the default compute options. When you start a workspace, you don't have to specify anything. These are pre-provisioned. They give you the fastest session start experience where you get your Spark sessions within 5 to 10 seconds. The next one is custom pools, where you get to tailor and you get to adjust properties such as node size, auto scale properties, min and max executors for if you need dynamic allocation or not, where you get to customize them based on your workload needs.
Question around this one real quick. While you're talking about this one, a question kind of came in on those custom pools that you have over here on the right-hand side.
Yeah.
Look, there's been an announcement, I believe it was at Fabric Conference, that the native Spark runtime engine is something that you can add to the Spark pools. So you have built your own runtime engine. Is that something that you would configure at the custom pool level, or would you also configure the native runtime engine on starter pools as well?
That's a very interesting question, and Ashit has like a separate section that we'll be going into native. But to your point, it is agnostic of the type of pools. So native is more at the runtime level. So irrespective of the pool option that you choose, are you going to go with a large pool, or are you going to go with a small pool for your like more interactive exploratory data analysis scenario? You could use in any option, any of these. You could just use
Awesome.
and you could also like have more granular control, which Ashit would be talking through how you could accelerate your performance using native execution.
That's a really good point. I want to very much point this out. As a data engineer who does things for companies, this is incredibly powerful for us. This is a huge tool. And the fact that I can configure things and make this stuff happen kind of dynamically and either starter or custom is a big win for us. So I really love the fact that you're giving us really a lot of power here for data engineering inside the Fabric tool. That's awesome. Sorry, I'll stop interrupting. Go ahead, keep going.
No, this is thanks for asking this question. So I have a QR code here. This is going to be a deep dive that we had a chance to do with one of my colleague Estra on Fabric Espressos. So this in this episode, I'll actually be talking more about what is Spark Compute and how you can actually customize this on different levels. Moving on. So now we touched upon Spark Compute. The most critical aspect is understanding your defaults. So Fabric, as we know, is an end-to-end unified analytics platform. There are different options that are set as defaults to offer a most performant end-to-end analytics experience. As you know, Mike, it's super important to make sure that you have a highly read optimized scenario so that your business users, they're going to be like thousands of business users consuming from your data products that you've created in the Go layer, or like from your aggregates. Through Power BI reports, it could be through applications that they build on top of it, and other dashboards, etc. So
yeah,
there are
I agree.
And you want to make sure that you shift the cost towards the left, so that when they're doing these concurrent reads, you have a low latency experience, and they're going to get the insights instantaneously.
That's a really good point that you bring up there, because this is one of the when we talk with customers. So we have a consulting business that we run as well, and this is one of the main points. Is in the past, I've been thinking about buying a SQL server that had storage and compute kind of all bolted into one ecosystem. Now with Fabric and Spark, we have the ability to take the compute system and make it separate from the storage system. And so this is the real power of what we're doing here. I'm literally getting goosebumps. I'm so excited about this. We have the capability to like really design table structure for exactly what we need. And we can optimize by making those materialized views, creating tables, bringing them down to the lakehouse. So that way, when we need to go get access, we have high performance, and we're doing a lot of just read against those large tables, which is huge. This is a different way of thinking than I think we've been thinking in the past around data engineering.
So true. And but when you say the system is tuned for this experience, it's super critical for enterprise users. Like when they are trying to like plan their data engineering workload, they want to know what are the defaults. So I've listed out a few of the defaults at a high level, and there are like 200 plus properties and other library configurations that are shipped as part of runtime. First one is when you start a workspace, the pool is always a startup pool. Like by default, you get a startup pool. It's of medium size, and then you, whenever you create a new workspace, it's going to have the latest runtime, which we went GA at FabCon 2 weeks ago. Ashit will be again diving deep more about that in later stage of the section. And the job admission. Job admission is going to be optimistic job admission. I'm not going too much in detail. Ashit will be covering this again, but these are going to be an intelligent cache. Again, these are all like enabled by default, so that you have the best experience end to end. Optimized write and reorder. That is also enabled, and that is for like again offering a better read experience when you're trying to like query these from engines like Data Warehouse or Power BI. I have listed the configuration, so this is something that users could use to get at the session level, like understand, okay, and get grounded on these are the configurations are like set as default. So if they would want to like tune their workload in a different way, because every workload is going to be unique and they're going to have like different requirements. So they could use this to fine tune their workload. So now we know what the defaults are. As we all know, Medallion architecture is one of the data engineering patterns. But again, the key emphasis that it's built around is more in terms of modularizing and having a layered approach. So as we move from right to left to right, the data quality improves, and it's more in terms of the data becomes more consumable, and you get faster insights. So it's going to be having 3 different layers where we actually have bronze, silver, and gold. Bronze being the raw landing zone where data is going to be unstructured. It's going to be in different formats altogether, and it's going to be in different. It's not going to be conformed. It's going to be messy. Primary reasons why users use the landing zone is for auditing or archiving. Want to make sure that later, if they want to do reprocessing, they don't have to go back to the sources. They could just easily do it from the landing zone. Next one is a silver layer, which is where the data quality rules are applied. Policies are set to make sure that the data is confirmed, filtered, and based on the business requirements to create entities which are going to be, again, used by data engineers and data scientists and analysts to create the business level aggregates in the goal layer, right? Which is going to be consumed and democratized in organizations. With that said, the compute for these different layers is not going to be a one size fits all. It needs to be custom fit based on different properties. And we saw about we talked about the defaults that are set. So here are some of the properties. Again, these are more like tips or guidances that we are sharing based on our discussions with enterprise customers. So if you want your bronze layer to be heavily write optimized so that you have more bandwidth to support your downstream SLAs for your data processing, the recommendations are increasing the checkpoint interval, because you're not going to be having like frequent reads on a table level, and at the Spark session level, disabling the order and optimize write, because you don't need larger file sizes or files to be optimized for reads, and also disabling collection of stats, because again, that's if you're not going to be querying against these raw data sets, you would not, you don't actually have to use these. The next important phase is, once you have set your bronze, your write optimized, moving on to silver. So silver is where silver is going to be an interesting one, because in certain cases it's in most cases it's actually right. It's meant to be write optimized, where you actually create these data entities, where you standardize the data sets. But there are also scenarios where users would prefer to run queries or do some analysis. So there could be a mix of both. So in those cases, again, we want to still make vOrder. We recommend it to be turned off, again, because it's not going to be like directly served by business reporting. But you actually have the bin file size property that we talked about, or the optimized write that we mentioned. By default, in Fabric, when you enable optimized write, the value is going to be set to like 1 GB. So users could set it to a smaller value, something like 150 to like 200, 250 MB, so that you still have like smaller files, so you have a higher rate of parallelism when you're performing writes in this layer, so that you could actually finish these jobs sooner, so you can move on to the next layer on like preparing these aggregates for business consumption.
These are really good concepts, and I love that you're going in the weeds and like and more in the detail around what silver and gold and bronze mean. And to be very clear, like I use this medallion architecture all the time. The medallion architecture is more like a methodology, right? And that's why this is why very clearly called out. Bronze is raw landing of data. Think of it as like, and how I explain it a little bit as well. It's an append-only method. It's the ability of continually getting new data. I'm not necessarily trying to update old records. I may have duplicate records for the same master data in this table. That's okay. And again, this is one of the mindsets. I'm just going to point out some here. When you come from a SQL world, you're not thinking in raw data. You're thinking about a staging table and then using that staging table to update your master table or your final tables. In the Medallion architecture, it's slightly different. Again, storage is cheap. We can write lots of data into the bronze layer and just let it sit there and just not access it very often. So that's the value of why we keep bronze. Then when you move over to the silver layer, I like to think in terms of this is where a lot of our cleanliness comes from. You have cleaning, like deduplicating your data, finding your product master, joining topical pieces of information together to make those clean tables. And we're starting. You can have many tables that live in the silver layer, right? You could have one table that builds 3 or 4 tables downstream, but still all be in silver. That's okay. Because sometimes people get in this mindset of I need one table per layer. That's not necessarily true. You build what works best for your business. And then as I think, Santosh, you're going to go here to the gold layer. This is where the magic kind of comes all together now. Like, why do we do all this?
Yeah. And as you rightly said, right? So in this case, the gold layer is where you curate these entities, and you want to make sure that when they are being read by like hundreds of reports across your organizations by thousands of users concurrently, you want to make sure that they have the best read performance. So as you see here, I would recommend like setting the properties of VRO to be enabled, and if you're if you've already like adjusted the bin size, then you would want to like increase it back to 1 GB. If you're not like touched bins optimized right, if it's going to be enabled by default. So you're going to be writing files in a larger chunks, like with 1 GB each. So you still have. So what happens is when Power BI or other engines are like trying to like read, they get more faster read performance.
This is great. This is something that I think is not very clearly understood. I'm very glad you're calling this out, because as you go through the different layers, you really are thinking about in each layer, what am I doing? Am I just always writing data down, or am I writing and needing some reading? And depending on what you're doing, if you have data scientists doing a lot of reads inside your silver, you may slightly tweak your parameters just ever so slightly. You may want to do some smaller or larger bin sizes for those files that are being created down at the Parquet level, because that would help them do their job better. So again, this is really cool. Not many people understand this. This is all brand new to us as we're coming from the Power BI world into Fabric world. This is stuff that's been known to Spark engineers, but now as us as business users coming in with more data engineering, we need to know this. We need to know how to tune these things.
Totally. And once, so now say, for example, you have set up these configurations and you have started running your workload, it becomes interesting where, again, based on our enterprise discussions with few enterprise customers who have already gone live and who have run into these scale challenges, right? Most of them are like able to like get what they require, but in certain cases where they have the mix of scenarios, like where they want to balance out between price performance or how to scale to their SLA requirements. And when they run into these issues, like during production scenarios, how do they make sure that they have options in place, and they're also like you're leveraging all the tools that exist in the product to make sure that they are able to understand the issues. So say, for example, they run into errors. How do they use Spark monitoring experiences more effectively to understand the different points of failure and the root causes, and resolve that as soon as possible to make sure that they don't impact their downstream SLAs. This next one is, say they identify an issue, and now most of the cases, users actually run into like data drift, where the input data runs into the experience Skew, and there are different ways in which you could identify and handle skews. Ashit would be going, would actually be doing a dive deep session on this once I hand it off to him, like in few minutes. And once they finish optimizing and optimizing their queries to handle these data skews, they want to make sure that this also scales. So there are going to be like 200 plus Spark properties. How could you use the existing capabilities such as Autotuning, where the system automatically tunes Spark based on your historic query performance, and how you could actually achieve a better job reliability when you have these recurring runs in your enterprise workload. So first one, the monitoring experience, right? In the case, say for example, you start running a job, the first part that's super important to understand is, are you provisioning the compute in the correct way? Like, is it too much for this job, or is the job actually like struggling and it has already hit this max scaling limit and it is not able to like scale further, where it is like taking super long to like complete, which is impacting your SLA. So the GIF on this slide actually talks about or explains the resource tab that you see in the monitoring view. So say, for example, you click on a job. In the job L1 view, you'd actually be able to see the total resources, the pool level configuration that are being provisioned. Now, when you click on resources preview, so this is something that Jenny on my team landed, and this is in public preview, so you'll be able to use it in all regions. So when you click on the resource preview, you will be able to see the entire lifetime of a job and how the executors have scaled up and scaled down as they are processing these different tasks throughout the lifetime of the job. In the cases where you feel that the purple line that we saw, which is the max allocated, and the blue line, which is the actively running executors. So when you see if your job is always having the blue line meeting the purple line, then it means that you're being like too constrained, where your jobs are not being able to like scale up when they need. And in certain scenarios, like the example that I'm showing here, where customers actually have over-provisioned the resources, right? So in this case, what this could lead to is potential starvation scenarios, where other jobs could have utilized these resources, or you could have bagged more, etc. Right? So this is one thing that I would start with.
And I'm going to add a little. I'm going to add a little point. I'm going to go add a point there if you don't mind. This is a great screen, and so this is one of the challenges as a developer of things in Spark. You run a job and you run a notebook, right? Something, it's doing some actions. When the heavy process, you use different processing at different times, right? If I'm doing a lot of read and writes, I'm going to use a lot of compute to do things. If I'm going to bring a lot of things into memory and keep things in temporary tables, I'm going to be using more memory in the job. And so the machines will, you have the range. This is where it's really cool. It scales up and adds more machines when it needs to. It can grab more compute. It can grab more cores, essentially, units, if you need them or not. This is going to be very important after you have some of your jobs written, because when you design your first notebook, you're not really going to know if it's performant or not. You might just throw it at a generic cluster and say, okay, here we go. So my pattern for development has usually been just build it, just get it running. And once you have it running, this is the step where we come back and now we can start optimizing a bit, right? Is this the right cluster? Do I need to not run it on a small cluster? Maybe it should be a big cluster. And another thing that I want to point out here is I think about processing data as area under the curve. This is very mathematical, like I know.
It is.
But it's like if I'm gonna process those records or that for that period of time, it's the same area under the curve. And I can either say, I'm going to do all the processing on one really big machine, so really scale out and say, okay, we're going to make a very large machine and process everything very quickly. Or I'm going to then limit my machine size and allow it to process a little slower over time. As an admin of Power BI, I'm very mindful of, am I on a smaller SKU? Is this happening in the middle of the night, or is this happening in the middle of the day? I may not want a very large cluster turning on at 9 a.m. in the morning when I'm trying to reserve capacity for my
Exactly.
So this is a really important thing as admins. You need to pay attention to this because this is going to help you balance your capacity to get everything done you need without having timeouts and errors and having things not being able to run. Because if you just shift a job by a couple hours, you might actually be able to process all your data in a more effective way. So I just want to bring some things that I'm observing in the same feature. Right? I'm doing this right now, so that's why it's so important to me.
No, that's super valid. And again, this is just a starting point, right? Now that you've set up your compute, you know whether you're over provisioned or not. Then comes the fun part. So say your job has been running good, okay, but suddenly I don't know, things can change. Like your data could have null values or could have some increase in data volume, right?
It happens.
So in these cases, the next step for fine tuning or like understanding where things went wrong is the run series view, where it basically shows an entire timeline of your historic runs. So from the same monitoring tab, on clicking on a job, you would be able to navigate to the monitor series option on the right, and then once you land on this page, you would actually see all the runs in a historic timeline, and it also highlights in red, like the bars that you actually see. These columns are actually like highlighted. The ones that are in red are called out as anomalies because something has changed. And it could be on a different level, right? It could be like number of bytes that were read, or the overall core allocation. Maybe your capacity admin downsized your capacity, or your pool is like your compute is like super small. So by clicking into each and every column, you would actually be able to get a high level view of all these properties. Again, this is more at an L2 level. Now, if you want to go even more deeper, you see that everything is green even on this. It's been consistent, but you still feel that your jobs are not optimized enough, or they are not meeting the SLAs. That's where the L3, or like the Spark history server based debugging would help, where you actually go click on Spark history server. Now that you landed on Spark history server, you would be able to select the application that you've run. In the application, you will be able to see the job level view, which is going to list all the jobs and the duration and the timeline for it. And the duration in this case is going to be at a single job within a Spark session. And then you would also be able to see the data volume that has been processed. And moving to the executors, you're going to be able to see the different executors that were added at different point in time. And you can also navigate to the query plans to see different tasks that are how each of these tasks have actually been executed. And is there and most of the cases, like in most of the enterprise discussions that we've been having, are complex scenarios, like with massive data volume. When enterprise customers come with these issues, I usually go through this route. And when I hit the data skew, say there is a large, there's not a proper distribution of data, that is when I actually go and trouble it. And that's the reason I also have him here. So handing it off to Ashit to take over the next parts of the presentation.
And this is really important. So let me be frankly honest with you. I'm a big user. I love Spark. I go up to this point. I've gotten a couple of, hey, well, let's talk about data skew. I'm like, I'm kind of losing it at this point. So this is going to be really important here. Let's hear from the expert of what are we talking about with the different data skews here? Because I think this is also important for us. This is, again, how we kind of think about what do we do in our notebooks. The code we write influences what we kind of see the results of here in the cluster. So I'm really excited about this part. Ashit, take it away, man.
Thank you, Santosh. Thank you, Mike. So what is Skew? Skew is basically, you have a number of problem and they're not going at the same rate. In this case, it's not people, it's threads, it's tasks, whatever. And so what I'll try to do is kind of create an analogy between a query plan and our daily lives and try to see how to match the two to give you an idea. But before I do that, kind of the reason why we are here and why we have this whole session is because we have tried to create a self-tuning service, so to speak, but there are still a lot of inputs we don't control, your data and your queries.
Yeah.
And they do have a deep impact on the eventual results you see. And as practitioners, even with Power BI, you've seen that before. The more work you can do ahead of time, the engine has less variation to deal with. And so while it's still a service where we try to do a lot on our own, there are things where we can work together with the end user to improve the overall performance. So and one very important interface is the data. And so when we're talking about Skew is heavily influenced by data. So let me go deeper into my analogy. Let's say today's Friday, I'm just about to go get lunch, and I have a concert to attend at the end of the day. Before I get to the concert, I have to get some work done. Before I get the work done, I have to go and have lunch with my team. Okay, so these are kind of the stages I want to have, and a query plan also has stages, just like your day has stages. And between stages, there are barrier points. I cannot go to the concert before I finish my work. Cannot finish my work before I finish lunch. These are kind of hard barrier points. Now, let's say I'm going to lunch with my team, and we're working as a team to the place where we're going to get lunch, and the place is busy, so they won't seat us down till everybody's there. Let's say Santosh is a little slow today in walking, right? So he's the Skew. He's causing me to not get a table till he gets there, right?
What are you doing? You got to get to lunch on time. Come on, I can't have this. This is not acceptable.
This doesn't happen in real life. Never.
He's always on time.
Yeah, he's always on time. And so that's a Skew. That's a stage where you hit a barrier point where you have to wait for everybody to catch up. And then we order lunch, and Santosh says, "Oh, I'm going to have the special today." So he goes and talks to the server. He has a chit chat, and then and we can't get out of our lunch place, and I can't get to doing my work till he gets his special, which he savors because he's a foodie and he likes the better things in life.
Right? So, I'm with you. I'm with you, man.
Come on. Now I can get to my concert in time if maybe I can get Santosh to speed up faster, and that's kind of the thing, right? So your daily plan is like a query plan, and if every stage can go faster, then the query executes faster. When you look at each stage, it's a parallel set of things happening. There are multiple threads or tasks going on, and if they do roughly the same amount of work, or more likely if one of them doesn't lag behind, then you are generally optimal. And so what I'm going to do, the 4 things I have here are actually from a kind of a research paper in the early 80s or so. Of course, theory has evolved over time, so I hope I won't bore you too much. But the reason I bring these up is because these are the common kind of things which we encounter. As engines has evolved, as Spark has evolved, we have been able to take and improve upon some of these things so that you don't have to do that. But there are still things you could do to help and notice these things and improve performance overall. So there are kind of 4 kind of skews. Tuple placement skew is basically a tuple is basically a row, right? Like your rows exist somewhere in files, and so how your rows are distributed amongst files is very important, because especially engines read a file at a time and then extract the rows. So if you have 2 files, one really large, one really small, they might not do the same amount of work. Santosh just happens to be carrying a very heavy backpack. That's why he's slow, right? So again, so you want to evenly distribute the work here. I'm picking on Santosh. Sorry, Santosh.
It's good. It's
my backpack is kind of heavy though. So.
That backpack is heavy just because there's all that work. The computer needs to be so big for all the processing we got to do. So it's a good thing.
So all right. So then we have one kind of skew there. Then the next kind of skew is, hey, let's say all of the files have an even amount of rows. but you have a filter which applies more to one file than the other file, right?
Mm-hmm.
Now, again, the next stage will do more work because let's say after that you have an aggregate, right? So that's selectivity skew. Then there's redistribution skew. So as you may have seen, when you go into a Spark plan or any distributed engine plan, one of the things a distributed engine has to do is move data around. It's called a shuffle. Well, when you shuffle things around, even though every file may have the same amount of data, you've selected the same amount of data, when you shuffle, you may end up doing more work on one node versus another node, or
Yeah.
one output versus another one. And similarly for joins, after you join them, join is like another filter, you could say, right? After you redistribute and you join, again, each task may end up with a different number of rows. And so when you think about optimizing your workflow or your query, what you want to do is, of course, you assume that your query is the full job which you're optimizing. Then
Mhm.
within it, you want to see that, especially in parallel systems, that all the elements working on it are doing the same amount of work so that the query can go the fastest. And
Yeah.
that's the reason why we focus on Skew. Skew is really, really one of
Great
the things,
explanation. This is
right?
good. Really good.
Right. Thank you. And the other impact of Skew is not only does it slow you down, but occasionally, and you see this in Spark queries, you might say, I hit an out of memory error. And it's because, again, there's a guy with a heavy backpack just collapses, right? Too many rows, a billion rows in one, in one, and 5 rows in another. You don't have enough memory on one node. You
Yeah.
see an query doesn't work. So
Yeah.
Skew is particularly pernicious, right? It's something you need to watch out for. And this is not the first thing you do, but when you get production ready, which is why it's in this talk, you start looking at these things to say, how will my workload scale? So what we have on screen here, thank you, Santosh, is you know how do you identify skew? So we have a couple of examples. One is, like I said, at every stage you could run a query equivalent to that stage. So if you're just reading data, then you just read the data and look at it. You can write basically queries to go identify skew at every stage. You could also look at your Spark history server. How does the query flow? How much data is read at each task, and how much data is written out at each task. You can look at the data wrangler and do some visualization. So there are multiple ways you could do this, especially if you find that you're fine tuning to that level of performance where you want really large jobs to work. I think we can go to the next one. And so, like I said, data engines have evolved and really are doing a much better job these days of handling these kind of skews. But there are still cases where you might have to watch out for. So tuple placement skew and selectivity skew, like I said before, you could try to adjust your size of files and your partition sizes so that they are nearly even. And this again comes to the bronze layer to silver layer tuning. In Spark 3.5 with Delta 3.2, there's liquid clustering. You may have heard of it. And liquid clustering in the silver layer kind of helps adjust some of these things. But it's still fairly new. We still have to make sure it gets integrated into the best practices. But it's an attempt to solve this problem and take it away from the user. But if your initial workload is still CSV files or some other data source, you might still have this problem, and that could cause perf problems, for you if you don't adjust that.
Can I ask you a question around liquid clustering? Because this is something a pattern that I've seen. So I work with Databricks and Azure as well, and this is a pattern that you see there with their liquid clustering. Liquid clustering is really kind of floating or being able to, just correct my direction here, I'm just trying to understand it. Liquid clustering is the ability for you to then change the number of files and how large those files kind of dynamically. It kind of just figures out, as you're accessing and reading and doing things to the data, the engine itself is making best guesses. Is, oh wait, this file size is way too big. It's generating skew, and so what the liquid cluster is doing is saying, I'm going to slowly over time kind of adjust some parameters on literally the definition of the delta table and say, look, I'm going to repartition things the next time I run the job to be a bit more efficient. And so that's, wow, okay, I didn't make that connection until you said that now, because again, I haven't had time to really dig deep into it, but that's a great explanation of you do want the engine to figure these things out for you, because one table has many files under the hood that support it. And so the liquid clustering kind of automatically adjusts that for you. That's really helpful. Awesome.
So it's meant to help exactly this tuple placement kind of
Sweet.
skew problems. So then there's also redistribution skew and join skew, like we said. And redistribution skew, basically we have adaptive query execution. So like we said, there's two parts, to a barrier stage. There's a shuffle, there's a write, and there's a read. Now, you try to control the right part of the shuffle with, let's say, the placement skew or the join skew. But let's say your data output is skew, then what do you do? And that's where adaptive query execution kicks in and tries to handle that. And so again, Spark has gotten much better over time to handle these cases, but these are things which still hit you. And sometimes, there's so much you can do. You also want to avoid, even getting into the stage where you have to run an adaptive query plan, because that is more work. Just like you said, liquid clustering is still more work because it has to adjust things. And so you could avoid that sometimes. And there are some options you can do. I wouldn't always recommend them. I would like to let the system do this. But in case you are stuck, you could tweak the number of partitions. Instead of using an even number of partitions, use an odd number of partitions or prime number of partitions, just so that you disturb the layout enough. And it still depends on what kind of skew you are hitting. It may work or it may not work.
Yeah.
So do that.
Cool.
Really
I didn't even
advanced.
know. I didn't even know about the that's a neat trick. An odd number, or you said a prime number, right?
Yeah, like just so that
Cool. A little bit of introducing. What do they call that? That is it's not noise, but it's like randomness, right? Add a little bit of randomness to it, and it kind of pushes things around. Oh, it's interesting. Okay, cool, wonderful.
It won't always solve the problem, because let's say you're dealing with states and Delaware, and you're selecting Delaware and California.
Yeah. They're going to be big.
Gonna be big
Every time.
So, exactly. But sometimes it may get you out of that.
Okay.
The really deep one is you can go use a custom partition function. I am not providing examples here, but this is just pointers so that you can, if you are really stuck in the space, you can research these things and go out there. It is possible. Spark is very flexible in this. All right. So we move to the next one. Again, like we said, we're trying to create a system which tunes itself, and you have to do much lesser work than you're maybe used to somewhere else. So we have something called Autotuning in Spark right now. It's in a preview stage. We only support 3 configurations. We're trying to learn and see user feedback as to what this is and how people react to this. The reason, because it's an autotuner, it tries things and sometimes it may fail, and not every customer is okay with things failing. It takes a little time to stabilize as well, somewhere around 10 to 30 iterations, depending on the complexity of the job. But in a lot of cases, we have seen this, come to the right answer within like 5 iterations. But that's why it's in a preview, but you can turn this on. Customers have told us it has helped them tune their queries faster. This is in some ways replacing a human. We suggest you try this on, see what it does for you. You can turn it off and look at its tuned variables and maybe copy that over if you want. But this is something which we want to take to production, and we are really looking for feedback from you folks. How many of you have tried this? What is your experience with it? Some of the ideas we have are we want to tune more variables. We want to see, what other areas can auto-tuning help besides tuning parameters. So this is an area, I would love to engage with more people, get more feedback, see how it works. It works well for the cases we have targeted, but we feel we can target a much broader set of cases, and we would love to see, more from folks in real life. What do they see? I think we should go to the next one, Santosh.
When you say auto-tune, I think a lot about the ability. Remember, there was an old app that you would talk into and it would auto-tune your voice. You say auto-tune, I keep thinking of like singing into that little phone app and having it auto-tune my voice so I hit the pitch on the notes and everything like that. So not audio auto-tuning. This is Delta Parquet tuning, what we're talking about here.
This is query performance tuning, yes. Yes.
A little more practical than my phone app singing to myself in the shower.
I might need it after this.
That's awesome.
All right. So I think the next one is very similar to kind of this. Is a very interesting one. This one is trading off reliability and perf in different directions depending on how we do it. So like we said, one of the frequent things we see is customers hit issues. Now we try to take care of as many as we can, but Spark is very extensible. You can use Python code. You can do lots and lots of things within your job, and sometimes you just need more memory. On the other side, you also hit. Yeah, thank you. I think I should have explained.
No, you're
Is
good. You
out of
said it
memory.
earlier. I'm just reiterating. You said is out of memory. So just for those who are just catching a little bit later, is out of memory errors. That's good. Keep going. Keep using We're good now. We've defined it. The variable's been defined. We're good to go.
Thank you. So one of the things is, like we said, we have one of the variables, and we talked about it this way, is the number of executors we run for the job. You were talking about the area under the curve,
Yeah.
and how to expand and contract, right? But that is an indirect number in a sense, and there is another indirect number which you can use, because given your executor size, you choose a number of CPUs, and by default, we say we'll start one task per CPU. Okay. Now, this is a good choice in general, but this is a choice which can be leveraged to your advantage if you know more about your workload. So, so we can go in two directions. We can say, hey, per CPU, instead of starting one thread, I want to start two threads. And why would you do that? Well, you would do that if your threads are not too busy. Let's say your first part of the workload is reading from some really remote storage. You're importing data from across cloud providers. Okay, you're very likely to be IO bound because of various reasons. At that point of time, maybe you say, you know what, most of my thread is what task is doing is it's waiting, it's issuing the read, and then it's just waiting. Instead of issuing one read, if I start up two tasks, I can get two reads in flight, and maybe things will go faster. So you can tweak this value, and I think we should go to the next slide, to say, hey, make it 0.5, and now you have two threads instead of one thread, and things go a little bit faster. Now, this works for other reasons also. The danger here is that each task may require a particular amount of memory, and if you haven't tweaked that correctly, then you have out of memory errors, and so then you have to go the other way around. So there are certain jobs which may have skew, that may have other reasons where they are not perfectly balanced with the amount of resources in the system, where you might say, hey, I want to give more memory to this task. And the way to do it is set this configuration to a larger value, because ultimately, if you look at our system, all the nodes which we provide to the customer, they have a fixed memory per core ratio across all the SKUs we used. And so basically, we're trying to take that choice away from you, because we maintain that ratio constant. But there are some occasions where a end user might say, this is my task, I need more memory per task. You don't offer me a new SKU, but here's what you can do as a user to get more memory per task. So this is a interesting one, because you can get perf on one side, but you may decrease reliability. And this is a slider you can play. We leave it at one. It works for most users, just works fine. But if there's a tricky query, you might need to do this. Now, the thing about this is you cannot set this at a per query level. And this is something we can think about in the future. This is a startup option. You would have to go change your pool config, so to speak, to make this happen.
Makes sense.
Okay, so we can sit here. Thank you. I see the excitement.
First note here, right? Smaller bars are better, right? Is that what we're talking about here?
Yes, smaller bars are better.
I want to call out, man. It's right above my head here. Native engine, baby. Let's go. This is just announced. I'm super excited about this. The native engine. I'm really excited to do more testing. I haven't done a lot yet, but I'm starting to get into it. I'm very excited about this feature. Awesome. Love this slide.
Thank you. And trust me, the team with me who works on this, everybody in my team is super excited about this.
I forgot to ask. I forgot to mention, this is free. This is the big, look at the bar Spark, Fabric Spark, and now native execution engine. You get this with no additional compute cost to you. That is, we're going to get there. I just have to say it now. I'm so excited. This has been really hard fought one. The team made a great decision on this. And for all of you Microsofties who may be listening somewhere, you did a great job by making this feature just included with the Spark engine. This is going to be a great differentiator for you. And anyone else listening, you need to take note of this because this is something you want to take advantage of.
Thank you, Mike. I think you hit the nail right on the head. Like, look, we know Apache Spark and the way it was written, at the era it was written, it was probably the right set of technologies there. But, I come from a database background, have worked, for years in that. We know tips and tricks to make engines go faster.
Yeah.
There's a lot of state of the art, which open source Apache Spark does not have, which we put in our Fabric Spark, and then we said, we can take it. By the way, I don't want to take all the credit here because, Fabric Spark with the native engine is built on top of Velox and Gluten, which are both open source projects, which we heavily contribute to from
Good.
Microsoft.
Love it.
There are lots of things we have delivered here to make the native engine kind of work, even in the open source, in a much better way. One of the things we did was memory management. These out of error messages, used to have to tweak every query setting so that it would work. And we've eliminated a lot of that work so that the user experience with use of the native engine is much, much better. So yeah, I was going to set up and say, hey, we can try to tell you, please go tweak these things, but what about just making everything goddamn faster so that you don't have to worry about it? And that is what the native execution engine is. It's
Love it.
our attempt to make things faster so that at a holistic level, maybe it just meets your threshold and you don't worry about it. And like you said, it's free. So, that should take away some hesitancy in terms of using it. The one reason why the slide is here is because, again, it is not a GA'd feature. And there's a reason why it's not GA'd is because, we are still working on fit and finish. So there are, for a lot of customers, it just works. There is one case which we are just today shipping out where support for legacy timestamp isn't enabled, and we are shipping that out. But having said that, you might occasionally encounter an issue where you say, oh my God, you guys hit a bug somewhere, which you have to fix. So we did not want folks to say it's a binary choice at the workload level. I turn it on or I turn it off, because that's a lot of gains you're leaving on the table. And so the reason why this slide exists is to say you can turn this off at a single query statement level. So you can turn it on and you can turn it off to avoid the bug which you hit. Please file a bug, please. We're very responsive.
Yeah.
We'll get it done. But
Yes.
that's why it's not GA. And we have seen a lot of users use this thing and benefit from it. We have seen our telemetry people, real customers are seeing 2 to 4x gains. We're super happy with where we are, and we know we are not done yet. There's a whole session at FabCon on this where we talked a little bit about our roadmap and so on. But yeah, my encouragement to you is use this, but be aware of the setting so that in case you hit an issue, don't decide, oh, I need to throw away the baby with the bathwater. There's a more precise fix you can do.
Awesome. And just to be clear, I mean, this is a command that you can run. Do you run this? There's a setting on the cluster. So there's a couple of places you can set this. You can set this on the cluster or the environment for your notebooks. You can set it at the workspace level, I believe, as well. And this is what you're showing here. The line of code you're showing here is, this is what I would run in the notebook to tell the notebook, okay, I'm going to run this notebook. This is the, you would probably do this, at the first part of your notebook, first command line?
No, that's what I'm trying to say. You could do it there.
We could. Yes.
You set this on in your environment, let's say.
Set it earlier.
You have, let's say, 5 notebooks. And 4 of them ran fine. The 5th one, has 20 cells. Till the 18th cell, it ran fine. The 19th cell, you had an issue. Okay, now you have a choice. Do I turn it off at my environment level, which is what we don't want you to do? You want to say, go to that 19th cell, turn it off there, run your 19th cell, turn it off again, 20th cell runs. And so,
cool.
This gives
I didn't realize. You said it. I didn't. It didn't connect for me yet. It didn't connect that we're talking like individual cells within notebooks. Flip it on, flip it off when you. Oh wow. Okay. That was new to me because I didn't know you could do that individually between cells.
Yes. So that's what we worked on. And that's why I was talking about like all the memory management and so on. Is to get rid of all of these, because otherwise you had to restart your application. It wasn't hitting live pools, a whole bunch of things just out of the door. we've tried
sweet.
to work to make it extremely usable. And so now
Cool.
you can do A/B comparisons for a single query. Run it before, run it after, see what it does.
Mhm.
You're happy, keep it, right?
Oh, I love this.
Which I hope you
Great
will be.
feature. Oh, this is solid, man. I love it. You're getting me more excited. Now I want to, you've ruined my whole afternoon now because now I have to go play with this stuff because these are all new cool features. Oh,
Hey, you
goodness.
have a concert to get to. But okay.
I do. Once we get done with lunch here, we're still waiting for people to finish their lunch. We'll get there, but
Exactly.
I love this. This is
All
great.
right. So as I know we said we'd go faster, so I'll speed up. So we've looked at individual queries up till now, okay? But we've not looked at the entire workload. And a lot
Sure.
of times, the feedback we're getting is it's not just the query. The query seems fine, native execution fine, everything fine. But my entire workload, because of our capacity approach and so on, is not as fast as I expected to, because we're being throttled and so on. So up till a few months ago, we had a very pessimistic approach, and then we have turned to what is called the optimistic approach. And the idea is, because we have auto scale on. So by the way, just as a primer, auto scale is basically if you run a query, as you know, a query has stages. We just talked about it. Each stage may take a different number of resources. Some could run with 10 threads, some could run with 20 threads. You don't want to have 20 nodes up and running and then use only 10 nodes. So we try to scale up, scale out. We inflate, deflate as fast as we can, so that you get the best performance. And the area under the curve in terms of the money you pay is optimized, right?
That's what I care about. I care about the money and the area under my curve. That's what I'm focusing on, those things.
I like that too, because you keep us honest, right?
Yeah.
So now, if you're a system which has to accommodate this inflation, deflation, so to speak, how many jobs do you let in? So one approach you could do is to say, hey, I know, Mike, you told me you'd use at max 20. So I'm going to reserve 20 and not let anybody use, X minus 20, because, hey, that's all what I have.
Yeah, I need it. I'm going to reserve 20. That's what I know I need later on to make sure, again, mission critical workloads. I got data that's going to executives. We've got to process this data to get it out the door. I don't want anyone else coming in using some of my capacity when I need it.
Exactly. But that is not always, a great choice for the end user, because now you have to go and tweak every single job you submit and specify the max correctly. And now what happens is, most of the time your job just uses 10. You're still waiting there. You're not paying for it, but at least on the Spark side, you're not paying for it. But you're still just waiting, and you're not utilizing the resources which you have provisioned, right? So what if we did a different approach, which is what we call the optimistic approach? We say we let everybody in, and you duke it out. When you need the resources, we give them to you if available. Otherwise, you wait a bit and you run a bit slower. And this is after a lot of feedback from people who were like, hey, I have a capacity, but it's not going. Oh, it's this setting, and so on and so forth. So now we have two approaches. So this is the optimistic one, where we say we let you in and we'll let you grow if there was actually capacity left for you to grow. Otherwise, you run with the capacity you have, and maybe you run a bit slower. And so the next slide is, of course, the pessimistic approach. Now, the problem with the optimistic approach is, like you just said, is this the variability. But most people who run their workloads and are tuning it kind of are doing it at the beyond the single kind of job layer, so to speak, and they're looking at overall utilization capacity. So they seem to be really happy with this approach as well. But there is a switch which you could turn on and off if you need to. We could go to the next slide. So this is another one, and this one is really, really popular with folks who say, hey, again, my jobs are a bit variable. So we are doing talking about sharing a single session within sharing a single Spark application across multiple sessions. And what we had conceived this feature was, we got a lot of input from data scientists saying, the way I run is, I run one notebook and I run another notebook and I open multiple notebooks at the same time. And, I need resources for all of that to run. Now, this collides with something which we do. So at Microsoft, we really care about security. And we do not want to create a system where we mix users in and then they can exploit, dump resources, because as you know, Spark is not a closed ecosystem. That's
No.
one of the biggest advantages of Spark, which means you can run arbitrary code. And one of the things you can do with arbitrary code is you could end up leaking secrets from folks who are in the same session as you. So one of the things we do is to say we isolate each job. So each notebook would have been in its own set of dedicated resources with maybe this with this pessimistic admission maybe, and they would be just blocking resources when, Mike, you're only typing in one notebook. I don't think you can still manage to type within two notebooks at the same time. And so,
I'm not that good. I mean, I'm good, but I'm not that
but
good.
yeah, I mean, life goals, right?
Yeah, life goals. Type in two. I'm gonna have to have two keyboards on my computer where I'm simultaneously writing code. Not there yet.
Not there yet. So you're not going to use it, right? And so
Yeah, no.
the clean feedback we got was, hey, I have 5 sessions, but I'm actually just going to use one resource because that's where I'm working, but my workflow requires these things. So can we have sessions which belong to me sit in the same Spark application so that I don't use, the multiple amount of resources? So that's what single session, session sharing was. We still aim to be extremely secure. So, we don't share, Santosh and I won't share the same session. If we both start using a notebook, we will get different notebooks different Spark applications because security is primary. But this is a mode, driven by the UX. You can go select the concurrent session, and this will, reduce your operational cost, so to speak. We should go to the next one. So this is great. Well, once you get hooked onto this, you're like, but why can't I have this for for jobs and scheduled jobs and pipelines? And so we announced this concurrency for notebooks and pipelines. You can use it again. Single user. We try to be secure. We do have a bunch of criteria where we say we will not share things if the environment is not the same, library is not the same. We don't want you to go figure out correctness issues. So again, as many times as we can, we'll put notebooks into the same session so that you save on resources. Again, remember, if two of those sessions, because these are jobs, so it's very likely they could run together. So if two of these jobs both require, I don't know, 10 executors to run, and your app was only configured for 10 to run, both of these will run at half the speed. So there's no free ride here because there isn't empty space to work with. And so you might want to end up tuning the overall job size, so to speak, but take advantage of our auto scaling the system will take care of it. But you might hit into those kind of things when you use this for pipelines, and you need to be aware of what's going on behind the scenes. Ultimately, you can only squeeze into so many people into a elevator, so to speak, right?
Yes.
So
I have one quick question around this one. So, thinking about pipelines. So, and a lot of times in pipelines, I run like one notebook, and that notebook needs to complete like the bronze layer, and then behind that, I may run a second notebook. So, what we're showing here is there's actually in this image right here, you have 3 notebooks, and they're running consecutively. The pipeline's calling. It's not that notebook doesn't represent the actual notebook. It's calling the action to go run the notebook. And so, in there, you're showing the session tag at the very bottom. And you're saying, just to make sure I'm clear, as long as that session tag is consistent across every single action in the pipeline, you are saying, oh, this session has been tagged. I'm going to run another session for the next notebook. Oh, let's just check to make sure the tag's not already existing. Oh, the machine's still running. Keep using that same machine and keep moving forward. This should save me some time in running the pipeline, because before I had to turn on Spark, run the notebook, shut down Spark. Oh, hey, wait, another notebook showed up, run up Spark again, go do some more things. Now, it doesn't take a long time to run up, but I was wasting a little bit of time in between each session. And frankly, if the machines, for me, right, the job 1 runs, we ramp up from 3 clusters up to 10. Well, we're already at 10 at the end of the notebook. I don't want to go ramp down and ramp back up again. Just stay on, keep running through the rest of the job. And I think this is really going to help make your efficiency run when you're doing multiple notebooks in the pipeline. This is something that I've been waiting for. Very, very pleased to see this one. And one technique I'm starting to use is we can even use pipeline parameters to set the session ID. And this is also really cool because now you can mix and match different sessions if you need to. meaning if you want a session ID for one notebook, you can have 2 sessions for a series of notebooks, and that way potentially you could have, if you're thinking about running things in parallel, right? I have 3 notebooks in one pipeline, and in the same pipeline, I have 3 different notebooks, not interdependent, but now I can provide 2 different session IDs, and then in parallel, it can do really cool things. So anyways, I think this is going to really open up a lot of features for companies. This is a very cool feature here.
It is a very cool feature. And, I think you hit the nail on the head. So there's the other use case, which is one was the kind of, hey, I want to reduce my COGS use case. The other use case you just talked about is the, hey, there's a performance hit. And especially when I use custom libraries, I don't hit your starter pools. My cluster startup takes up time. Can I just keep the cluster warm? This is how you do it. So thank you for bringing that up. And it is very, very useful because, again, a lot of you guys have like SLAs. I want to finish this within 3 minutes or whatever, 10 minutes. And can I just get it done? So thank you for that.
Yeah, this is good. I'm using the feature right now today. I love it.
Thank you so much. All right. So over to you, Santosh, to close us out. Thank you so much.
Appreciate it.
Awesome. So again, we touched upon different topics, right? Like since the introduction, we talked about, just to give a recap, because it was across like different areas. So first thing that we want to make sure that we emphasize that you customize and you tailor your compute requirements and configurations based on your zones, how you're organized, if you want it to be read optimized or write optimized. And the configurations that we talked about and the properties that Ashit mentioned, we want to make sure that you understand your workload. And if you hit the Skew, you have these tools or like options for you to like configure once you set these up. Then we actually also want to touched upon, Ashit went super deep on ways in which how you could partition and how you could actually get the performance by default experience. I mean, the system is built in a way, as Ashit mentioned, like it's built in a way that you get perf by default without doing much, but you still have like customized workload requirements. Each and every workload is going to be super unique, right? So you have these options in terms of spark.task.cpus. Like if you want to like have a better reliability for a complicated workload where you've not had a chance to go and repartition, you are in a time crunch, you can use these tips to like adjust it so that your job runs where completing the job is much more important than getting it faster, right? It's again a balance. Next one is maximizing compute utilization. You want it like there are different ways. Native execution engine, as you mentioned, it's free, so it's going to give you acceleration at every query level, and options like optimistic job admission or high concurrency mode for like scheduled runs or interactive runs is going to allow you to like do more for what you end up paying for the area under the curve, like for the job runs that you're trying to like do on Fabric. So I think that's all we had for today's session. Would love to hear more feedback from folks watching online or like folks who are actually like watching the recording later. So feel free to like share feedback, how we could actually, some of the problems, if we do not cover some of the problems that you hit into or like you constantly run into where you're finding it hard to like, which is causing a adoption blocker or like going live with Fabric at enterprise scale, right? So would love to hear your thoughts. And yes.
We really appreciate your time today. Gentlemen, thank you so much for your time. I know it's been a little bit longer than an hour. I was very engaged. This was awesome. The chat is asking questions. I was answering some questions there as well. So thank you very much. Really appreciate this one. You better pay attention to this one because this is going to change how you do data engineering in the future. This is good stuff. You're going to love it. So thank you all very much. Really appreciate the presentation. And with that, we'll have it wrap. And, let us know if you like this content. Please make sure you give us a thumbs up or add some comments to the video. We really want to know what you want to learn about next. We can definitely get people back on and talk more about in detail around specific things to help you build better Fabric environments and specifically data engineering.